When you look up at the night sky, what do you really see? Little pinpricks of light scattered across the darkness, or the edges of something far bigger, a vast city of stars that we call a galaxy. And then, another question follows quietly behind the first one. You see, where exactly are you in all of this? Not just your town or your country, but your true cosmic address, written in stars and dust and invisible threads of gravity. Tonight, I suppose, we are going to drift together from the familiar into the immense, guided by one simple word: astronomy. Astronomy is, in a way, our way of leaning out of the window of Earth and looking at everything beyond it. It is the study of stars, planets, galaxies, and the universe itself. But it is also the study of us, because every answer out there whispers something about where we came from and where we are going. And that is the thing. A galaxy is not just a pretty swirl in a picture. It is a gigantic community of stars, gas, dust, dark matter, all held together by gravity, all moving, changing, evolving over billions of years. Our own Milky Way is just one such galaxy, one among perhaps hundreds of billions spread through the observable universe. And yet for us, it is home, the quiet little neighborhood in which our sun and our small blue planet reside. In this journey through 100 facts, we will start with the basics, step by gentle step, and then move deeper into structure, evolution, collisions, and the distant future of galaxies. Think of it as walking a path, from the first simple question, what is a galaxy, to the deeper, more unsettling one. What does it mean to be human in a universe built from these immense islands of stars? Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. You know, when we speak about astronomy, we often imagine enormous telescopes or faraway galaxies printed on glossy textbook pages. But perhaps the more interesting question, the one that lingers just beneath the surface, is simply this: what happens when a curious human being lifts their eyes from the ground and decides to wonder? Astronomy. Well, it begins exactly there. It is the scientific study of everything beyond Earth, yes, but beneath that definition lies something far more tender, almost fragile, a desire to understand our place in a universe that existed long before any of us learned to speak its name. And you see, the moment we look up, we are already participating in the oldest conversation humanity has ever had. Astronomy stretches outward toward stars, planets, galaxies, and the vast cosmic ocean itself. But it also stretches inward into memory and imagination. Sometimes, I suppose it feels as though every star we study is also quietly studying us. The universe reflects itself through us, through our questions, through our longing to know. And that's the thing. Astronomy is not simply about objects hanging in the void. It is about relationships, about how light travels, how gravity gathers matter, how time leaves fingerprints on everything it touches. It is, at its heart, the unfolding story of existence. And in that story, galaxies play a role so grand that they almost defy the limits of human language. A galaxy is a gigantic collection of stars, gas, dust, dark matter, and all manner of cosmic structures, bound together by the gentle but unyielding pull of gravity. Perhaps think of it like a city, but a city made not of concrete and steel, but of suns, millions to trillions of them, each one burning in its own quiet corner, each one performing its own luminous dance. When you look up at the night sky, the stars you see belong to our galaxy, but that faint river of light across the sky, the one we call the Milky Way, is not a trail of stars at all. It is a cross-sectional glimpse into the disk of the galaxy itself, like looking through the thickness of a forest rather than across its edge. And the word galaxy has its own story too. It comes from the Greek word meaning milky, a reminder of that glowing band that ancient observers traced across the heavens long before the word astronomy existed. I suppose there is something beautiful in the idea that even our language carries stardust, shaped by the sky our ancestors once feared, worshipped, or navigated by. But galaxies, they are not sprinkled randomly like confetti across the universe. They follow patterns written not in ink but in gravity. These invisible structures stretch across cosmic distances, forming vast filaments and threads, almost like the stitching on a quilt. You see, on the largest scales, gravity creates a kind of architecture, an intricate web that guides where galaxies live and how they move. If you could step outside the universe and look back at it, well, which of course you cannot but imagine, you might see something that looks like a network of luminous veins pulsing with ancient light. And inside our own galaxy, the Milky Way, our sun is just one star among hundreds of billions. One. It is humbling, isn't it? To think that everything we know, everything we have ever loved or feared or dreamed of, is happening around a single star in a galaxy full of others. It is like discovering that the village you grew up in is just one settlement in a vast continent teeming with life. And yet, despite the enormity, our place in this cosmos is not insignificant. It is simply small, delicately small, like a grain of sand that nonetheless contains the memory of an entire beach. Galaxies are key to understanding how matter in the universe is organized and how it evolves over time. They are the stage on which stars live and die, where planets form, where the chemistry of existence is brewed. Without galaxies, stars would have no stable homes, and planets like Earth would likely not exist. Imagine that for a moment, a universe full of lonely, drifting stars without orbits, without companions, without the gravitational embrace that allows stability. It is within galaxies that stars find shelter, that gravity shapes their relationships, that systems like our own have the chance to form. Sometimes, when you walk late at night and the world around you grows quiet, you might feel time stretching, slowing, almost pooling around your feet. And in those moments, perhaps the universe feels closer. Astronomy often begins with that quiet feeling, the sensation that there is more out there than what daylight reveals. And from that feeling, questions arise. What are we made of? Where does our story intersect with the story of the cosmos? And why, in a universe so vast, do we feel such an intimate affection for the stars? If we trace the arc of the facts from this first chapter, we find ourselves slowly stepping outward, from Earth to the sun, from the sun to the Milky Way, and from the Milky Way to the great cosmic structures beyond. But for now, here, lingering within Chapter 1, we are simply laying the foundations. Astronomy as the study of everything beyond Earth, galaxies as colossal, gravitationally bound communities of stars and matter, the Milky Way as our home among billions of others, and the subtle recognition that without galaxies, and without the structures they create, life as we know it could not unfold. There is something deeply human about this awareness. We are creatures of curiosity, and the more we learn about the universe, the more we seem to learn about ourselves. Our questions shape the cosmos just as the cosmos shapes our questions. And this is the beginning of a journey through 100 facts that will take us from the familiar glow of our own galaxy into the immeasurable dark between galaxies, into collisions, into the distant future where galaxies drift apart, and even into the cosmic address that defines our place in all of this. But before we can drift too far, we should pause for a moment. You see, understanding what a galaxy is requires us to appreciate not just its structure, but its scale. And scale is a strange thing in astronomy. Distances become so immense that ordinary measurements collapse under their own inadequacy. We cannot speak in kilometers or miles. The universe refuses to be reduced to such earthly units. And so we reach instead for something shaped by light. As we move gently toward the next chapter, toward the fabric of distance itself, we begin to sense that galaxies are not simply objects. They are landmarks in a cosmic landscape. And to find our place among them, we must first learn to measure the space between the stars, the space between galaxies, and the space between the earliest moments of the universe and the quiet now of 2025. And so, perhaps it is time to continue walking, to let the path lead us from what a galaxy is to how far away its neighbors truly are. Because the next question, the one that naturally follows, is simple but astonishing. How big is the universe in which these galaxies float? And that, is where Chapter 2 begins its quiet unfolding. Well, let us continue from that quiet threshold where we left off, standing between what a galaxy is and the astonishing distances that stretch between them. You see, once we understand the nature of a galaxy, the next natural question is not about composition or shape, but about scale. How far away are these islands of stars? How do we measure the space between them when even the nearest is unimaginably distant? And why, I suppose, does distance itself become a window into the past? These are the questions that gently pull us into the second part of our journey, into the realm where numbers grow so large that language strains to contain them. And yet, even here, even in this vastness, we find something beautifully human. Curiosity, reaching beyond its own limits. The space between stars and galaxies is so enormous that ordinary measurements simply collapse. Kilometers, miles, they become little more than children's toys when held up against the true scale of the cosmos. So astronomers had to reach for something else, something that belongs to the universe itself: light. The distance between stars and galaxies is so huge that astronomers use light years instead of kilometers. A light year is not a measure of time, though the name tricks many into thinking so. It is a measure of distance, the distance light travels in 1 year. And since light moves at the fastest speed allowed by the universe, it becomes the perfect cosmic ruler. 1 light year is about 9 trillion kilometers, which is a number so large that speaking it aloud feels a little absurd. But perhaps that absurdity is part of the wonder. A single beam of light, leaving a star, races outward for a full year, and only then covers that distance, 9 trillion kilometers. And that is just 1 light year. When we step back and consider our own home galaxy, the Milky Way, we find that it stretches across roughly 100,000 of these light years. Imagine that, if you can. 100,000 years of uninterrupted travel at the speed of light, just to cross from one end of our galaxy to the other, and somewhere, tucked away not even near the center but off in a quiet spiral arm, our sun drifts, carrying Earth along with it, both of them taking part in a slow, majestic orbit around the galactic core. Our everyday world, traffic, birthdays, conversations, sleepless nights, is happening inside something unimaginably large, something with a diameter carved in units of light. And then, beyond the Milky Way, lies our nearest large neighbor, the Andromeda Galaxy. It sits at a distance of about 2.5 million light years. 2.5 million years at the speed of light. And that means something extraordinary. The light from Andromeda that touches your eyes tonight began its journey long before human beings existed as a species. Long before the first tools. Long before language. Some of those ancient photons began their journey when our ancestors were no more than upright apes wandering across warm savannas. It is strange to think that the light we see now is older than our oldest stories. And perhaps that is why astronomy often feels like time travel. Because it is. In fact, when we look at distant galaxies, we are literally looking back in time. The further away a galaxy is, the longer its light has been traveling, and the younger the universe was when that light began its journey. Some galaxies are so far away that their light began traveling toward us before Earth even formed, before oceans, before continents, before anything that resembles life. So when we observe those ancient galaxies, we are witnessing the early universe directly, as though we have found a window cut into the past, Sometimes, when I think about that, I get this strange sense that the universe is not just large, it is layered. The night sky becomes a kind of cosmic museum, each galaxy a display behind glass, showing us a different era. Nearer galaxies show us the universe as it is now. More distant ones show us the universe as it was millions or billions of years ago. And the very farthest, those faint smudges barely detectable even with our finest telescopes, show us the universe in its youth when it was just beginning to form structures. And if we keep pushing outward, if we allow our imagination to travel beyond the Milky Way, beyond Andromeda, beyond the small families of galaxies they belong to, we eventually reach the edge of what we can observe, the boundary of the observable universe. Within this sphere, whose radius stretches tens of billions of light years, lie all the galaxies whose light has had time to reach us. Tens of billions of light years. Think about that for a moment. A sphere of space so vast that it would take a beam of light longer than the entire history of Earth to cross it. But even that is not the whole universe. It is only the part illuminated for us by time. Perhaps that is the most humbling aspect of cosmic distance. It reminds us that we inhabit a universe where time and space intertwine. We are not just seeing faraway objects. We are seeing ancient versions of them. The universe is showing us a timeline stretched outward in all directions. And each dot of light carries not just distance, but history. You know, there is something almost poetic in the idea that the night sky is full of ghosts. Not frightening ones, but gentle remnants of past galaxies, past moments, past cosmic ages. The light is their message, sent long before the first human heart ever beat. When you look up, you are not seeing what is, but what was. And that's the thing about astronomy. It is not passive observation. It is active listening, listening to stories told by light. So, well, how do we make sense of it? How do we live in a world where the distances are so immense that even our imagination feels too small to hold them? I suppose the answer is that we do what humanity has always done. We translate the incomprehensible into understanding, slowly, patiently, one fact at a time. We place ourselves on a cosmic map, even if the map is far larger than our minds can fully grasp. And when we think about the scale of the universe in 2025, we find ourselves living in a time where technology finally allows us to peer farther than ever before, to detect the faintest whispers of galaxies that formed shortly after the birth of the cosmos. Our telescopes gather not just light, but time. Our measurements stretch into realms the ancients could never have imagined, and our understanding continues to expand, just as the universe itself expands. But scale, you see, is not just about distance. It is also about connection. These immense measurements link us to Andromeda, to galaxies far beyond it, to the cosmic web of structures that define the shape of reality on the largest scales. And as we stand here at the end of Chapter 2, drifting between awe and comprehension, we begin to sense that learning about distance is not enough. To understand where we truly are, we must turn our gaze inward again, toward the Milky Way, toward the structure and story of our own galactic home. And so perhaps now, as the universe continues to expand quietly around us, it is time to step from the vast emptiness between galaxies into the swirling, luminous architecture of the one we belong to. Because if distance tells us how far we are from everything else, then the Milky Way tells us who we are within our own cosmic neighborhood. And that, you know, is where the next chapter begins to rise gently on the horizon. And so, as we drift from the vast distances of the cosmos back towards something a little more familiar, we find ourselves approaching the great spiral of stars that we call home. You see, it is one thing to know how far away other galaxies lie, but it is another thing entirely to understand the structure of our own. The Milky Way sits before us now, not as a distant object, but as the very stage upon which our story has unfolded. And perhaps that makes this chapter feel a little more intimate, a little more like looking through a family album of the cosmos itself. The Milky Way is what astronomers call a barred spiral galaxy. That phrase might sound technical, but the idea is simple. Imagine a spiral, like the swirl of cream in a cup of coffee, but with a long, bright bar of stars running through the center. That is the Milky Way's heart, a glowing bar from which great spiral arms extend outward, curling gently into the dark. These arms are not solid structures. They are waves of density, regions where stars, gas, and dust are more concentrated, like traffic bunching on a cosmic highway. And our sun, well, it lives quietly within one of these arms, a modest little spur called the Orion Arm, not in the center, not at the edge, but somewhere in between, like a house on the outskirts of a grand city. Astronomers estimate that the Milky Way contains between 100 and 400 billion stars. A range that wide might seem imprecise, but the scale is so immense and the dust so abundant that counting stars becomes an act of patient inference rather than certainty. Still, even the lower estimate is staggering. 100 billion suns, each with its own story, its own orbit, its own potential for planets. And ours, just one, sits at a distance of about 27,000 light-years from the galactic center, in a relatively calm, stable region where life had the chance to unfold on a pale blue world. The Orion Arm, where the solar system resides, is not one of the grand primary arms, but a smaller, quieter one, tucked between two larger spirals. I suppose that makes our home feel a bit like a peaceful suburb within a vast and bustling metropolis. Here, the sun takes roughly 200 to 250 million years to complete a single orbit around the center of the galaxy, a journey sometimes referred to as a galactic year. Imagine that. All of human history, every civilization, every story we have ever told, fits within the tiniest fraction of one orbit. The last time the sun was in this position, Earth's continents were shaped entirely differently, and life was emerging from ancient seas. The Milky Way's timeline stretches so far beyond ours that our entire species is just a momentary spark along its long rotation. Now, if we travel inward toward the center of the Milky Way, we arrive at a region far more crowded and turbulent than our gentle neighborhood. The core is packed with stars, gas, dust, and an immense and mysterious presence, a supermassive black hole known as Sagittarius A. It sits at the very heart of the galaxy, exerting a gravitational pull so strong that stars whip around it at incredible speeds, not falling in, but dancing, as though performing a cosmic ritual in honor of the dark center that binds the galaxy together. This black hole is millions of times more massive than our sun, yet so compact that it occupies a space small compared with the scale of the galaxy around it. And yet, without it, the Milky Way might not hold the structure it does. It is a silent anchor, shaping the motion of stars in the core. From Earth, however, we do not see the Milky Way from the outside. We cannot float above it and admire its spiral. Instead, we see it from within, as a faint, milky band stretching across the night sky. That gentle glow is the combined light of countless distant stars seen edge on through the disk of the galaxy. For ancient observers, it was a river of milk, a pathway, a celestial road. And in a way, they were right. It is a road, one that winds through the history of the galaxy and leads us into deeper questions about our place in the cosmos. The disk itself, where most of the stars reside, is only a few thousand light-years thick compared with its vast diameter. Imagine a dinner plate stretched across space, so wide that its thickness becomes almost insignificant by comparison. And surrounding this disk is something we cannot see with our eyes, but can measure through its gravitational influence. A massive halo of dark matter. This halo extends far beyond the visible stars, enveloping the Milky Way in a kind of invisible cocoon. Within it lie ancient star clusters, relics from the early days of the galaxy, orbiting quietly in the dark. They are like old memories, preserved at the edges of our cosmic home. And you see, the presence of dark matter tells us that the Milky Way is far more than what we can observe directly. Most of its mass is hidden, shaping the movements of stars like a puppet master pulling invisible strings. Without dark matter, the galaxy would fly apart. The stars in its outer regions would not be held in their orbits. So the Milky Way, like all galaxies, is built from light and darkness both. A luminous disk held together by unseen forces. When I reflect on this, I often find myself imagining the galaxy as a kind of great cosmic city. At the center lies the bustling downtown, crowded, energetic, full of gravitational drama. Out in the suburbs, along the spiral arms, stars like our sun live quieter lives, giving rise to the possibility of planets and oceans and the slow unfolding of consciousness. Far above and below the disk in the halo, ancient clusters drift like elder citizens, watching from a distance, carrying with them the memory of the galaxy's earliest chapters. And beyond it all, an invisible envelope of dark matter keeps every piece in place, like the quiet architecture of an old and patient universe. In 2025, our understanding of the Milky Way is still incomplete. We cannot see all of it. Dust obscures the central regions, distance hides the farthest stars, and the dark matter halo remains a mystery that we can measure but not touch. Yet every year, with every new telescope, we add another brushstroke to the portrait. We learn more about the bar at the center, the structure of the arms, the rotation of the disk, the distribution of ancient clusters. The Milky Way becomes clearer, brighter, more familiar, not just a galaxy, but our galaxy. And perhaps that familiarity is what makes this chapter feel so different from the last. In Chapter 2, we were drifting through immense emptiness, measuring distance with beams of ancient light. Here, though, we are wandering the rooms of our own home. We are learning the layout of the galactic house we were born into, understanding where we stand in relation to its heart, its halo, its arms. And in doing so, we discover a sense of belonging that is surprisingly comforting for a species so small in a universe so vast. Yet the Milky Way, magnificent as it is not the only kind of galaxy out there. Far from it. Our home is just one example, one architectural style in a universe full of diversity. Spiral galaxies like ours, elliptical giants, delicate lenticular forms, chaotic irregulars. Each one tells a different story of formation, evolution, and destiny. And so, as we leave the familiar glow of the Milky Way's spiral arms behind, perhaps it is time to step back once more and look outward again. Not at the distances this time, but at the shapes, at the structures galaxies take, at what they become when gravity sculpts matter on the largest scales. Because to understand our galaxy is to understand a single piece of the cosmic puzzle. To see the whole picture, we must explore the others. And that, you know, is where the next chapter gently begins. And so, from the slow turning of our own spiral home, we begin to drift outward again, letting the glow of the Milky Way fade just enough for the silhouettes of other galaxies to emerge around us. You see, once we understand where we live, the next question arrives almost naturally, almost shyly. Are all galaxies like ours? And if not, how do they differ? What shapes do they take when gravity and time sculpt them across billions of years? This is where the universe becomes something like an artist, painting with stars and gas and dark matter, creating forms that are familiar, strange, elegant, chaotic. And well, in 2025, with new images constantly streaming down from orbit and the largest telescopes on Earth, we can see these shapes with breathtaking clarity. Galaxies come in several main forms: spiral, elliptical, lenticular, and irregular. These are not labels meant to limit them, but ways to make sense of the great diversity scattered through the cosmos. I suppose it is like walking into a vast library where every book is a galaxy. Some are orderly, some are ancient, some are torn and wild, and some sparkle with new stars forming inside them. And as we wander through this celestial library, each type tells us something different about how galaxies live, grow, and change. Let us begin with the spirals, since we are most familiar with them. A spiral galaxy is a disk, flat, thin, delicate, lined with graceful arms that wind outward from a central bulge. Imagine the whirls of a seashell or the swirl of storm clouds, but stretched across hundreds of thousands of light years. Within these arms lie regions thick with gas and dust, the raw ingredients of stars. Spirals are busy places where new suns are constantly being born. They glow with the blue light of young, hot stars. And our Milky Way, being a barred spiral, belongs to this family of luminous whirlpools. Then come the elliptical galaxies, which could not be more different. These galaxies are more rounded, sometimes nearly spherical, sometimes stretched into soft ovals, lacking the elegant arms of spirals. They often contain older stars, redder and cooler, because most of their gas and dust, the fuel for star formation, has been used up or stripped away. Ellipticals are like old cities whose factories have long gone silent, where the population ages slowly, quietly, with little new birth. They can be small, or they can be the largest galaxies in the universe, immense islands of ancient stars glowing with a gentle amber light. And you see, their lack of structure does not mean simplicity. Instead, it tells a story of collisions and mergers, of smaller galaxies gradually consumed, their shapes smoothed out like clay blended and kneaded over billions of years. Between spirals and ellipticals lies a quieter form, the lenticular galaxy. These galaxies look almost like spirals that have grown tired. They have a disk, yes, but little visible spiral structure, as though the arms have faded or been stretched thin. Lenticulars often contain less gas than spirals, meaning their star formation has slowed, perhaps even stopped. They are transitional objects, the in-between chapters of galactic evolution, offering clues about how galaxies change lifestyles across cosmic time. A spiral might one day become lenticular, and a lenticular might drift slowly toward ellipticity as collisions or internal processes strip away its remaining gas. And then there are the irregular galaxies. These are the wild ones. They have no regular shape, no symmetry, no familiar pattern. Some look like smears of starlight, some like shattered remnants, some like distorted ghosts of former spirals. Irregulars often arise when galaxies interact or collide, their structures pulled and twisted by gravity's invisible hands. Under such stress, gas clouds can compress, triggering bursts of star formation, lighting irregular galaxies with brilliant newborn stars. They are chaotic, unpredictable, and yet full of vitality. And perhaps it is precisely this irregularity that makes them so captivating. They remind us that the universe is not static or orderly, but dynamic, restless, and creative. Now, as we stand among these types, we begin to see a deeper pattern. Spiral galaxies tend to have lots of gas and dust. This abundance of raw material fuels the continual birth of stars in their arms. If you were to drift along one of these arms, you would pass through vast stellar nurseries lit by the soft glow of new suns emerging from clouds of gas so thick they obscure themselves from view. Spirals are, in many ways, the fertile gardens of the universe. Elliptical galaxies, by contrast, have little gas or dust left. Most of it has been used up in earlier eras, or heated and pushed away by violent processes. Their stars are older, their light more muted, their colors redder. They are like ancient civilizations that had their age of building long ago and now simply endure in the quiet dark. And the shape of a galaxy can change over time, especially when it interacts or collides with others. Gravity, you see, is both sculptor and destroyer. When two galaxies pass close together, their shapes stretch, twist, distort. A spiral can lose its arms. A small galaxy can be torn apart. A quiet lenticular might steal gas from a passing neighbor and spark new star formation. And in the grandest cosmic dances, galaxies merge, becoming something entirely new. Shapes evolve, identities change, and the universe continues its cycle of creation and transformation. Sometimes, I think of galaxies the way one might think of living beings, not alive, not conscious, but capable of change, growth, and aging. Spirals, full of youthful energy. Lenticulars, shifting into maturity. Ellipticals, ancient and stable. Irregulars, chaotic and impulsive. And yet these categories are not walls. They are snapshots of a moment in time. A spiral today might be an elliptical tomorrow, if tomorrow spans billions of years. And irregular galaxies, with their distorted shapes, often hold within them the seeds of future spirals, once the turbulence settles. In 2025, our telescopes continue revealing galaxies that challenge our categories, galaxies that blur the lines, galaxies that remind us that our labels are human attempts to understand something far larger than ourselves. The universe does not owe us neat classifications. It simply creates, destroys, merges, twists, and evolves across vast timescales, while we do our best to interpret its stories. And as we drift among these varied shapes, perhaps one question begins to rise quietly in the background. What lies inside these galaxies? Stars, of course. But how do they live within their cosmic homes? How do they cluster, form, age, and die? The light we see from galaxies, spiral, elliptical, lenticular, irregular, is nothing more than the collective glow of billions of stars. So if we wish to understand galaxies, truly understand them, we must turn our attention inward again, toward the stars that fill them. And that, gently leads us into the next chapter, where we explore the lives of those stars, small, large, dim, brilliant, and how together they shape the galaxies that cradle them. And so, from the swirling shapes of galaxies, spirals blooming like cosmic flowers, ellipticals glowing like ancient embers, irregulars twisting in wild and wonderful ways, we drift inward again. You see, a galaxy is not defined only by its form. It is defined by the light within it, and that light comes from stars. Billions upon billions of them, each one a small furnace burning in the dark, each one carrying the memory of the universe inside its core. If galaxies are the grand cities of the cosmos, then stars are the citizens, living out their luminous lives across millions or billions of years. And well, perhaps that is the most beautiful thing about wandering through the universe, realizing that everywhere you go, everything you see, is a product of stars being born, shining, dying, and beginning the cycle anew. Every visible star you see in the night sky is part of our Milky Way. That alone is a humbling thought. We often think the sky is full of countless galaxies scattered across the darkness, and while that is true, the points of light we recognize with our naked eyes belong entirely to our own galactic home. The universe beyond is simply too faint, too far, too subtle to be revealed without instruments. Yet even within our local patch, the variety of stars is astonishing. They range from cool, dim red dwarfs, tiny, steady lanterns that burn slowly across trillions of years, to hot, massive blue giants that blaze fiercely and briefly, their lives as intense as they are short. The diversity is staggering, and most stars are not like our sun at all. In fact, most stars in the galaxy are smaller and dimmer, quietly humming along in the background, too faint to be seen without a telescope. Stars, contrary to how we often imagine them, rarely form alone. They are born in groups, in vast clouds of gas and dust called stellar nurseries. These nurseries are among the most breathtaking structures in the universe. Enormous regions where gravity gathers material into clumps that eventually ignite into stars. Imagine a cloud large enough to hold thousands of suns, lit from within by newborn stars whose light begins to sculpt and shape the gas around them. These nurseries can stretch for hundreds of light years, and they glow in rich colors when observed with telescopes tuned to the right wavelengths. They are the cosmic equivalent of forests in springtime, full of life, potential, and change. Star clusters emerge from these nurseries, families of stars born from the same cloud, sharing the same age and composition. Some clusters are loose and sprawling, like open clusters, where the stars drift apart over hundreds of millions of years. Others are ancient and tightly bound, like globular clusters, which orbit the galaxy in its halo. These clusters hold some of the oldest stars in existence. Many formed not long after the universe itself began to cool from the heat of creation. And perhaps when we look at them, we are seeing something like the universe's earliest memories, old, stable, and still glowing faintly after all this time. Young star clusters often lie within the spiral arms of galaxies, where gas and dust are most concentrated. These regions are like neighborhoods bustling with activity, where new generations of stars continue to emerge. And as these stars grow older, their evolution becomes a kind of quiet language written into the structure of the galaxy. Massive stars burn quickly, living fast and dying young. Their deaths are spectacular. When they exhaust their fuel, they explode as supernovae, scattering their enriched guts into space. And it is in these violent moments that the galaxy is seeded with heavier elements, the building blocks of planets, oceans, and life. Every atom of oxygen you breathe, every atom of iron in your blood, every grain of calcium in your bones was forged inside a star and released in one of these final, brilliant eruptions. Smaller stars, like our Sun, lead much longer, more measured lives. They burn quietly for billions of years, gradually fusing hydrogen into helium, then evolving into red giants before shedding their outer layers in gentle waves. These layers drift into space, forming delicate planetary nebulae that often glow in soft blues, greens, and reds, while the core left behind becomes a white dwarf, a dense ember that will slowly cool for trillions of years. Stars do not last forever, but they do leave behind legacies that become part of the next generation. In this way, the galaxy recycles itself. Over time, these stellar life cycles contribute to the chemical evolution of entire galaxies, enriching them, piece by piece, with all the ingredients necessary for complex structures like planets and eventually life. You see, stars are not just points of light. They are storytellers. They hold within them the narrative of time, the transformation of matter, the relentless creativity of the cosmos. When astronomers peer into the light of a star, they are reading a kind of cosmic diary. The colors of that light reveal the star's temperature, its composition, its age, its motion. It is as though the star is whispering its personal history into the instruments that receive its photons. And perhaps the most astonishing truth is that the galaxy, any galaxy, is shaped not only by the stars that fill it, but by the stars that die within it. When massive stars explode, their shock waves can compress nearby gas, triggering the birth of new stars. In this way, death becomes inseparable from creation. One generation gives rise to the next, and the galaxy continues to evolve. In 2025, our understanding of stellar populations has become richer than ever. We can trace star clusters throughout the Milky Way, measure the ages of stars across different regions, and piece together the history of our galaxy based on these luminous clues. We can see which parts of the galaxy are still forming stars and which have grown quiet. We can map the distribution of stellar nurseries, trace the remnants of ancient supernovae, and unravel the chemical fingerprints left behind by generations of stars. And through all this, we begin to understand that a galaxy is not a static object, but a vast ecosystem, alive with motion, change, and renewal. Sometimes, when I think about all of this, I imagine walking through a city at night, seeing lights of different colors and intensities in the windows. Some shine brightly, others dimmer, some flicker, some go out. New lights appear as buildings rise, and old neighborhoods fade as time reshapes the landscape. A galaxy is like that, a city of stars, alive with generations overlapping, each one contributing to the structure and story of the whole. Yet even as we marvel at the stars within galaxies, we must remember that the story does not end there. If stars shape galaxies, then something else shapes the very centers of galaxies themselves. Something darker, heavier, stranger. And as we drift slowly from the spiral arms and glowing clusters toward the cores of galaxies, we begin to sense that the next chapter of our journey pulls us deeper toward the gravitational hearts that anchor entire galaxies in place. Because where stars illuminate, Something in the center of nearly every large galaxy exerts a different kind of influence, silent, powerful, invisible. And that, is where our path gently turns toward the next chapter. And so, as we drift away from the luminous neighborhoods of stars, their births, their swirling nurseries, their explosive deaths, we find ourselves being gently drawn toward the hearts of galaxies. You see, every journey through a galaxy eventually encounters a moment of stillness, a gravitational hush at the center, where something immense, something profoundly mysterious resides. It is a place where light bends, where time stretches, where matter spirals inward in a final brilliant dance. And well, perhaps nothing in the universe captures our imagination quite like these dark, hidden engines at the cores of galaxies. Almost every large galaxy is believed to have a supermassive black hole at its center. That alone is astonishing. It means that at the heart of nearly every one of the hundreds of billions of galaxies scattered across the universe lies an object so dense, so powerful, so strange, that not even light can escape its grasp. These are not the remnants of stars. They are far larger, far heavier. They anchor galaxies the way a deep root anchors a vast tree. Our own Milky Way's central black hole is called Sagittarius A. And though we cannot see it directly, we can watch the stars that orbit near it. They move incredibly fast, whipping around the center like comets around a bonfire. These stars trace out invisible forces, their motions revealing the presence of something massive and compact. One star, in particular, completes its entire orbit in just a handful of years, a blink of an eye compared with the ordinary timescales of the galaxy. It is as though these stars are telling us a secret, a whispered message. Something enormous lies here. Supermassive black holes can have masses millions or even billions of times greater than the sun. Imagine compressing millions of suns into a region smaller than the orbit of Mercury. That is the scale we are dealing with. And yet, despite their size, black holes are not cosmic vacuum cleaners sucking in everything around them. They influence nearby stars and gas through gravity, but much of the galaxy orbits peacefully, unaffected by their direct pull. Their influence is both gentle and absolute, shaping the structure of a galaxy without dominating it. Still, when gas and dust do fall toward a supermassive black hole, something remarkable happens. Instead of disappearing silently into the dark, the material forms a bright spinning disk called an accretion disk. Friction within this disk heats it to extreme temperatures, causing it to shine more brilliantly than entire galaxies. It is one of the great paradoxes of the universe. The brightest objects we observe are powered by the darkest ones. In some galaxies, the central black hole is so active, so voracious, that it transforms the entire core into what astronomers call an active galactic nucleus. And in the most extreme cases, these become quasars, objects so bright they can outshine every star in their host galaxy combined. Quasars are beacons from the early universe, some shining from distances so vast that their light began traveling toward us before Earth existed. They tell us that in the young cosmos, galaxies were more chaotic, gas was more abundant, and black holes grew with ferocious intensity. To look at a quasar is to peer into a cosmic furnace burning at the edge of time. And perhaps the most surprising thing is that the activity of a central black hole can influence how and where stars form in the rest of the galaxy. Jets of energetic particles launched from near the event horizon can stretch across thousands of light years, heating gas and preventing it from cooling enough to form new stars. In other cases, shock waves from the feeding black hole can compress gas clouds, triggering new bursts of star formation. A black hole, silent and invisible, can act as both destroyer and creator, shaping the destiny of an entire galaxy. This interplay between darkness and light, between gravity and energy, between destruction and creation, these are the forces that sculpt galaxies over billions of years. And yet, when we step back and reflect, we realize that black holes are not monsters. They are part of the natural architecture of the universe, as essential as stars, as ancient as time itself. In 2025, our understanding of supermassive black holes has grown deeper than ever before. We have photographed the shadow of one. We have watched stars trace perfect ellipses around another. We have detected gravitational waves rippling outward from black hole collisions. And each discovery adds another layer of awe to our understanding. These objects, once imagined only in theory, have become some of the most powerful tools we have for studying physics under extreme conditions. And yet, even as we marvel at the centers of galaxies, we must remember that galaxies are not made only of stars, and not shaped only by black holes. There is something softer, more diffuse, drifting through the spiral arms and glowing in vibrant colors, gas, dust, and nebulae. These are the raw materials for the next generation of stars. They are the cosmic scaffolding upon which new light is built. They fill the quiet spaces between stars with potential. They are both the cradle and the grave of stellar evolution. So, as we leave the gravitational heart of galaxies behind, perhaps it is time to drift outward again, into those misty regions where stars are born and die, where clouds of dust shimmer under starlight, where the galaxy breathes in cycles of creation and renewal. And that, is where our journey naturally turns toward the next chapter. And so, leaving behind the immense gravity wells at the hearts of galaxies, we drift outward again, as though stepping from a dense, bustling city center into the quieter outskirts where the air feels thinner and the space between lights grows wide. You see, galaxies are not just collections of stars and black holes. They are threaded through with something softer, something far more delicate, enormous clouds of gas and dust. And perhaps, this is where the story becomes almost poetic, because these clouds are both the beginning and the end of stars. They are cradles and graveyards at the same time, regions where creation and dissolution exist side by side. Galaxies are not made only of stars. They also contain immense reservoirs of interstellar gas and dust. And although these clouds might seem empty when compared with the density of a planet or a star, in the grand scale of the galaxy, they are essential. Interstellar gas is mostly hydrogen and helium, the two lightest elements in the universe, simple, ancient, unchanged in their essence since the dawn of time. These are the same elements forged in the first few minutes after the Big Bang, still drifting quietly through the universe, waiting, in a sense, to be gathered into something new. Nebulae, the great tapestries of the cosmos, are large clouds of gas and dust that can serve as either stellar nurseries or remnants of dead stars. They come in many shapes: filaments, wisps, arcs, pillars. And though they often appear faint or invisible to the unaided eye, they glow with extraordinary beauty when observed with sensitive instruments. Each nebula tells a different part of the galaxy's story. Some represent birth, others death. Some are carved by the light of newborn stars, others sculpted by the shock waves of ancient explosions. Emission nebulae glow because high-energy light from nearby hot stars excites the gas within them. These young, massive stars shine so fiercely that they strip electrons from atoms in the surrounding cloud. When the atoms recombine, they release light of specific colors, often deep reds and greens, creating the luminous structures we see in photographs. These nebulae are like cosmic lanterns, revealing places where star formation is vigorous and ongoing. They are the beating hearts of the galaxy's youthful regions. Reflection nebulae, by contrast, do not glow with their own light. Instead, they shine by reflecting starlight off tiny dust particles. These nebulae often appear blue, because blue light scatters more effectively than red, just as Earth's sky appears blue in daylight. Dust in these nebulae acts like a cosmic mirror, catching and scattering light from nearby stars, creating hazy, ethereal regions where starlight seems to drift like mist across the cosmos. These nebulae remind us that even the smallest particles, grains of carbon, silicates, ices, can shape the appearance of entire regions of space. Then there are the dark nebulae, the most mysterious of all. These do not glow or reflect. They hide. They appear as dark patches because thick dust blocks the light behind them. They are silhouettes against the brighter regions of the galaxy, cold, dense pockets where new stars may be forming deep within. Inside these dark nebulae, gravity quietly works, gathering material into clumps that may one day ignite. Observing them feels like looking at the closed bud of a flower. You cannot yet see what will emerge, but you sense the potential within. Over time, star formation and stellar explosions recycle gas and dust throughout the galaxy. A star is not simply born and then discarded, it participates in a grand cycle. When massive stars explode as supernovae, they produce shock waves that ripple through the surrounding gas. These shock waves can trigger new waves of star formation, compressing the gas enough to overcome internal pressure. And in their explosions, they scatter heavier elements, carbon, oxygen, iron, into space, enriching the interstellar medium. These elements become part of new stars, new planets, perhaps even new life. It is a kind of cosmic breathing. Gas collapses into stars. Stars fuse elements in their cores. Stars die and return material to space. New stars form again from that enriched gas, and the galaxy evolves, not quickly, not dramatically, but with the endless patience of cosmic time. The balance between star formation and gas supply helps determine how a galaxy evolves. If the gas is abundant and cool, star formation continues. If the gas is heated by shock waves or by the activity of a central black hole, it may become too warm to collapse, and star formation slows. Some galaxies, especially ellipticals, have used up or lost much of their gas, becoming quieter and older. Others, like many spirals and irregulars, still hold vast reservoirs of material, glowing with the promise of new generations of stars. In 2025, our understanding of these delicate processes has grown astonishingly deep. With infrared telescopes, we can peer through dust clouds that once hid star-forming regions entirely. With radio telescopes, we can trace cold hydrogen gas across entire galaxies. With X-ray observatories, we can map the shock waves of supernova remnants. And step by gentle step, we are learning not just where stars form, but how the conditions of their birth influence everything that follows. Sometimes when I think about nebulae, I imagine walking through a forest at dusk. The air is full of shadows and drifting light, shapes half seen, half suggested. The forest is alive, though quietly so. Things grow, decay, transform, all at a pace too slow for the human eye to grasp. Nebulae feel like that. Vast, silent forests of gas and dust where creation unfolds across millions of years. Their beauty is a reminder that even in the emptiness of space, nature is at work, sculpting forms and forging stars. And if you allow yourself to drift deeper into that imagery, floating softly through a cold, quiet nebula, you begin to realize that the galaxy is far from empty. It is full of breath, full of motion, full of cycles that repeat endlessly, long before we arrived and long after we are gone. These clouds of gas and dust are not just passive structures, they are active participants in the shaping of galaxies. They determine where stars appear, how densely they cluster, how long star formation continues, how the chemical richness of a galaxy evolves. Without them, galaxies would be nothing more than islands of aging stars dimming slowly in the dark. With them, galaxies become living systems, renewing, evolving, surprising. And perhaps that is why this chapter feels like a shift in tone. We have spoken of stars and black holes, of spirals and collisions. But here, in the soft glow of nebulae, the universe feels intimate again, almost gentle, fragile even, as though the galaxy, for all its grandeur, is also built from tiny grains of dust, from wisps of gas, from silent clouds waiting for the next star to emerge. You see, to understand a galaxy fully, we must understand its raw materials, because those materials are the threads from which everything else is woven. And once we understand the fabric, we can begin to understand how galaxies came to be, how they formed in the early universe, how they grew, how they collided and changed, how they became the immense cosmic cities we observe today. So as we drift quietly away from the glowing clouds, the dark patches, the the newborn stars hidden within drifting dust. Perhaps the next question rises naturally in our minds. How did all of this begin? How did galaxies first take shape in a universe still young and hot and expanding? And that, is where our journey gently turns toward the next chapter. And so, as we drift away from the quiet, drifting clouds of gas and dust, the birthplaces of stars and the soft, glowing lungs of galaxies, we feel the universe shifting tone again. The nebulae fade behind us like morning mist, and something older, rougher, more ancient begins to rise on the horizon of cosmic time. You see, if nebulae are the cradles of starlight, then galaxy formation itself is the birth of the structures that cradle everything else. To understand where galaxies come from is to understand where the great architecture of the universe began to take shape. And well, perhaps this is where the story becomes truly humbling, because the origins of galaxies lie deep, in a time when the universe was still young, still hot, still finding its structure. Astronomers believe that galaxies began forming when the universe was only a few 100 million years old, a moment astonishingly early compared with the 13.5 billion years that have passed since. Imagine that. The first galaxies flickered into existence when the cosmos was still glowing from its own birth. Space was denser then, richer with hydrogen, helium, and dark matter. There were no stars at first, only clumps, ripples, and subtle patterns left behind by the earliest moments of expansion. But gravity, patient and tireless, began to pull matter together. Small clumps merged under gravity to build larger and larger galaxies, and in those merging clumps, the first stars ignited, lighting up the darkness like sparks rising from a young fire. Early galaxies were often smaller, more chaotic, and formed stars at very high rates. The universe then was more crowded, more turbulent. Gas flowed freely. Collisions were common. The first galaxies were not elegant spirals or majestic ellipticals. They were messy, irregular, full of rapid star formation that churned out young, hot stars glowing blue against the blackness. These galaxies were like cosmic cities being built, while people were already moving in and building homes. Noise, energy, creation, all happening at once. Over billions of years, many small galaxies merged to become the large galaxies we see today. This, perhaps, is one of the most striking truths about the universe. Growth comes from union. Mergers are not rare events. They are the rule. Gravity pulls galaxies together, sometimes gently, sometimes violently, blending their stars, their gas, their dark matter halos. A small galaxy swallowed by a larger one disappears, but not in vain. Its stars continue to shine, now part of a greater whole. In this way, the cosmic architecture we see today is built from the remains of countless smaller structures. In the early universe, the rate of star formation was much higher than it is now. Galaxies were energetic, almost frantic, converting gas into stars at a pace that seems extravagant compared with the present day. They were younger, more active, more dynamic. Today, many galaxies are quieter. Gas supplies have dwindled. Energetic processes have heated or expelled much of the raw material needed to sustain such frenetic starbirth. It is as though galaxies have aged, moving from their wild youth into a more measured middle age. As galaxies age, they tend to use up or heat their gas, which slows down star formation. Gas can be heated by supernova explosions, by the energetic winds from giant stars, or by radiation and jets from central black holes. Warm gas cannot collapse easily under gravity, so fewer stars form. The galaxy changes character. A spiral full of bright blue stars may gradually grow dimmer, transitioning toward a quieter state where redder, older stars dominate the light. A galaxy is not static. It ages, evolves, and in the process, its appearance changes dramatically. Feedback from supernovae and black holes can blow gas out of galaxies or heat it, so it cannot easily form new stars. Feedback is a delicate and powerful concept. The idea that the stars a galaxy forms help shape what the galaxy becomes. Massive stars die explosively, sending shock waves that can push gas away. Black holes feed violently, launching jets of energy that heat gas on enormous scales. These processes influence the entire galaxy, regulating star formation, limiting growth, shaping structure. In a way, galaxies are self-governing ecosystems, shaped by the very stars they produce. Studying galaxies at different distances lets astronomers see different stages of galactic evolution. This, I suppose, is one of the great gifts of light travel time. Light from distant galaxies began its journey billions of years ago. When we capture that light now, we are seeing the galaxy not as it is, but as it was when the universe was younger. So by observing galaxies at various distances, astronomers can see the universe's history laid out in layers. Nearby galaxies show the present day. Farther galaxies show earlier eras. The most distant galaxies show the infancy of the cosmos. The night sky becomes a time machine, revealing how galaxies formed, grew, collided, and matured. And perhaps this is where the emotional weight of the story settles in. Because you see, in 2025, astronomers have begun to observe galaxies so distant that they formed mere hundreds of millions of years after the Big Bang. These galaxies are faint, fragile, ancient flickers of light that have traveled across almost the entire visible universe to reach our eyes. And each one is a message from a time when the cosmic web was first beginning to glimmer with starlight. What we learn from these early galaxies helps us understand not just how the universe grew, but why it looks the way it does now. Why spirals spin with elegant symmetry. Why ellipticals sit like old giants in galaxy clusters. Why irregulars scatter across the sky like bright, chaotic sparks. The story of galaxy formation is the story of everything we see when we look up. Sometimes, when I reflect on this, I imagine the early universe as a dark ocean of possibility, where tiny ripples of density acted like seeds. Over time, gravity nurtured those seeds, pulling matter toward them, letting structures grow, first small, then large, then immense. And here we are, billions of years later, looking back at that long chain of becoming, tracing the path from nearly featureless space to the incredible richness of galaxies. And perhaps the most astonishing part is that the process is still ongoing. Galaxies continue to merge, stars continue to form, gas continues to flow along the filaments of the cosmic web. The universe is still sculpting itself, still evolving, still writing its biography in the language of light. So as we drift forward from the story of galaxy formation, letting these ancient processes settle gently in the mind, another question begins to rise. Quietly, naturally. If galaxies grew by merging, if gravity constantly pulls them together, then what happens when these giants actually meet? How do galaxies interact? What becomes of their stars, their gas, their shapes? And that, is where our journey leads next, into the swirling drama of galactic interactions, collisions, and the cosmic choreography that unfolds when galaxies collide across the vast reaches of space. And so, drifting forward from the strange and turbulent dawn of galaxies, we enter a new landscape, one not defined by creation alone, but by motion, encounter, and transformation. You see, galaxies are not isolated jewels hanging quietly in the dark. They move, they wander, they feel the pull of gravity across unimaginable distances. And over billions of years they meet, sometimes gently, sometimes violently, sometimes with an elegance that feels almost choreographed. And well, perhaps this is one of the universe's most surprising truths. Galaxies live not in solitude, but in a cosmic dance that spans ages. Galaxies are constantly moving and can interact with one another through gravity. Even now, as you sit wherever you are in the world, our own Milky Way is gliding through the cosmic web, pulled by invisible currents of dark matter and the gravitational influence of nearby galaxies. It may feel strange to think of something as vast as a galaxy drifting like a ship through a silent ocean, but that is exactly what is happening. This motion is slow on human timescales, but relentless across cosmic eras. Given enough time, paths cross, orbits tighten, gravity whispers, and galaxies respond. When two galaxies pass close together, their shapes can be stretched and twisted. You might imagine them colliding like solid objects, but galaxies are mostly empty space. Instead, gravity pulls gently but insistently on their stars, gas, and dark matter. Spiral arms can be drawn out into long, elegant tails. Gas clouds can be compressed or torn apart. A galaxy may lose its symmetry, becoming distorted, warped, or threaded with bright new regions. It is as though the galaxies momentarily forget their old forms and begin reshaping themselves under a shared gravitational influence. And yet, despite how dramatic these encounters look in photographs, stars rarely collide directly because they are so far apart. This always astonishes people hearing it for the first time. Two galaxies can pass through one another, their stars intermingling like two flocks of birds crossing in the sky. Yet the individual stars almost never strike each other. If the sun were the size of a ping pong ball, the nearest star would be thousands of kilometers away. Space within galaxies is vast. So when galaxies collide, it is not their stars that crash together, but their gravity, their gas, clouds, their shapes, their histories. Still, these interactions are far from gentle. Colliding galaxies can trigger bursts of new star formation as gas clouds are compressed. Imagine two waves colliding and rising upward. The same happens when two galaxies meet. Gas clouds crash into one another, compressing under the force. The pressure increases, temperatures rise, and suddenly, regions that were once quiet ignite with the birth of new stars. These starburst events can produce thousands of stars at once, lighting up the galaxies with a fresh blue brilliance. It is strange to think that destruction and creation can occur together, but in the cosmos, they are inseparable companions. Over time, two colliding galaxies can merge into a single, larger galaxy. This is not a quick process. It can take hundreds of millions, even billions of years. The galaxies orbit one another, spiraling inward like dancers locked in an embrace. Their shapes blur, their stars mingle, their gas settles. Eventually, the two become one, larger, heavier, reshaped by the union. And the new galaxy that emerges may look nothing like its parents. Spirals can merge into ellipticals. Irregulars can merge into spirals. The forms we see today are the outcomes of ancient mergers, cosmic genealogies written across time. Elliptical galaxies are often thought to form from the mergers of spiral galaxies. This idea reveals something profound about galactic evolution. Spirals, with their delicate arms and rotating disks, can be disrupted easily by collisions. When two spirals of similar size merge, their orderly rotation is disturbed. Their gas falls toward the center. Star formation surges, and eventually the structure relaxes into a smoother, featureless shape, an elliptical galaxy. What was once a grand spiral becomes a glowing oval of older stars, a monument to past collisions. And sometimes, hidden deep within the light of an elliptical, astronomers find the faint signatures of its former identity: tidal tails, shells, faint streams of stars, the fossils of ancient interactions. The Milky Way and the Andromeda Galaxy are slowly moving toward each other and are expected to merge in the far future. This fact, perhaps more than any other, makes the idea of galactic collisions feel personal. One day, billions of years from now, the sky above Earth, if Earth still exists, will be transformed. Andromeda will grow larger over the centuries, appearing first as a faint smudge, then a bright arc, then a sprawling structure stretching across the sky. Eventually, the two galaxies will collide, their stars passing harmlessly through one another, while gas clouds collapse in spectacular bursts of star formation. The Milky Way will slowly lose its spiral structure. The two giants will dance, twist, merge, and the final result will likely be a massive elliptical galaxy, sometimes nicknamed Milkomeda, a single luminous island born from two ancient spirals. Galaxy interactions help build structure in the universe and change galaxy shapes over billions of years. Without these encounters, the universe would look very different. Spirals would remain spirals forever. Galaxies would not grow. Star formation would not be reignited by tidal forces. The cosmic web itself would lack the diversity we see today. Collisions sculpt galaxies. They enrich them. They move stars into new orbits. They blend chemical histories. They change the distribution of dark matter. They are essential to the narrative of the universe. And when we consider all this, the motion, the merging, the reshaping, we begin to understand that galaxies are not static islands but evolving, interacting participants in a vast cosmic ecosystem. They feel the gravitational tug of neighbors, the currents of the cosmic web, the flow of dark matter, the ripple of ancient waves. Their shapes are temporary. Their structures shift. Their stars migrate. Their gas cycles. They are, in every sense, alive across cosmic time. Sometimes when I think about galactic collisions, I imagine standing on some distant world, watching a second galaxy rise in the sky like a ghostly bloom of light. The horizons would glow with unfamiliar patterns. New stars would flicker in regions where gas is compressed. The night would become a canvas of motion, change, and awe. And perhaps, from such a vantage point, you would feel the universe stretching into a scale beyond comprehension. Beautiful, overwhelming, endlessly creative. And yet, even these colossal events are only one part of the story. You see, galaxies do not roam the universe entirely alone. They gather in families, groups, clusters, superclusters. They link together across vast filaments of dark matter. And beyond the local drama of collisions lies an even larger structure, a cosmic architecture both grand and delicate. So as we drift away from the swirling dance of merging galaxies, letting their tidal tales fade behind us like trails on a dark sea, perhaps a quiet question begins to rise. What lies beyond individual galaxies? How are they arranged? How do they gather? What structure do they form when viewed on the largest scales of all? And that, is where our journey turns next, into galaxy groups, clusters, and the vast cosmic web that binds the universe together. And so, after watching galaxies collide and merge, after witnessing their long, slow dances across billions of years, we begin to sense that even these grand interactions are only part of a much larger structure. You see, galaxies do not drift through the universe as lonely wanderers. They gather, they cluster, they weave themselves into patterns so vast and delicate that the human mind can barely hold them. And perhaps this is where the story grows even more astonishing, because when we zoom out far enough, galaxies reveal not solitude but community. They reveal belonging. Galaxies are rarely alone. They often live in small groups or large clusters. In fact, the image of a single galaxy floating quietly in empty space is more myth than truth. Most galaxies have neighbors, sometimes just a handful, sometimes hundreds, sometimes thousands. Gravity binds them together, drawing them into shared motion, interwoven destinies, and long-term relationships that last for billions of years. These families of galaxies form the backbone of cosmic structure. Our own Milky Way belongs to a small group of galaxies called the Local Group. It is a modest gathering, really, just over 70 galaxies, most of them small dwarf galaxies orbiting the two giants, the Milky Way and Andromeda. Together, they form something like a small cosmic village in the vastness of the universe. If the cosmos were an ocean, the Local Group would be one cluster of islands rising above the waves. And perhaps when you look into the night sky, it is comforting to know that our galaxy is not drifting alone through the dark, but is part of a quiet, gravitationally bound family. But farther out, beyond our gentle Local Group, exist far larger structures, galaxy clusters. A single galaxy cluster can contain hundreds or even thousands of galaxies bound together by gravity. These clusters are some of the most massive structures in the universe, colossal cities made not of buildings and roads, but of galaxies, hot gas, and dark matter halos. The sheer scale of them is breathtaking. Imagine a region of space spanning millions of light years, packed with galaxies of every shape, spirals spinning like cosmic pinwheels, ellipticals glowing like embers, irregulars scattered like broken shards of starlight, all of them moving in a shared gravitational field, all of them contributing to the total mass of the cluster. Between galaxies and clusters lies hot, thin gas that shines in X-rays. This gas is astonishingly hot, tens of millions of degrees, and so diffuse that a cubic meter would contain just a handful of particles. And yet, spread across the enormous volume of the cluster, it adds up to more mass than all the stars in all the galaxies combined. It forms a faint, invisible glow that only X-ray telescopes can reveal. These clouds of hot gas are relics of ancient collisions, leftovers from galaxies stripped of their material by the fierce gravitational forces at play within clusters. The total mass of a cluster is dominated by dark matter rather than visible matter. This is one of astronomy's great revelations. Galaxies and gas account for only a fraction of a cluster's mass. The rest, most of it in fact, is dark matter, an invisible substance that shapes the structure and evolution of the universe. Dark matter forms the hidden scaffolding that holds clusters together, preventing them from flying apart. Without dark matter, clusters could not exist in the form we observe. Its presence is detected not through light, but through its gravitational influence, bending the paths of galaxies, and even the light passing through the cluster. In this way, dark matter reveals itself by hiding. And when we zoom out even farther to scales that dwarf even the largest clusters, we see that galaxies and clusters form a vast pattern called the cosmic web. This web is not a metaphor. It is a structure that truly exists, a vast tapestry woven across the universe. The cosmic web is made of long filaments of galaxies and dark matter separated by huge empty regions called voids. These filaments stretch for hundreds of millions of light years, connecting clusters together like the branches of a cosmic tree. And between them lie the voids, immense, hauntingly empty regions where galaxies are few, where matter is sparse, where the universe rests in deep stillness. The large-scale distribution of galaxies gives clues about the origin and composition of the universe. The patterns we see today, clusters, filaments, voids, are the result of tiny fluctuations in the early universe, amplified over time by gravity. They are the frozen echoes of the cosmos's earliest moments, preserved across billions of years. By studying how galaxies are arranged, astronomers learn about the nature of dark matter, the influence of dark energy, and the physics that shaped the universe mere moments after its birth. In a way, the cosmic web is like the fossil record of creation itself. And often, when I think about these immense structures, I imagine wandering through them as though walking through an ancient forest. The clusters are like dense groves full of life and activity. The filaments are pathways, long corridors connecting one place to another. The voids are quiet clearings, vast and still. And through it all runs the unseen framework of dark matter, the ancient bones of the cosmos, supporting everything that shines. In 2025, our maps of the cosmic web have become more detailed than ever. Telescopes surveying millions of galaxies reveal the great filaments stretching across space. Computer simulations recreate the birth and growth of the web with astonishing fidelity. And each new discovery brings us closer to understanding how the universe evolved from a smooth, glowing sea of matter into the intricate structure we see today. Yet, as grand and vast as this picture is, it somehow still feels like a single layer of a much deeper story. Because even though we can map the cosmic web, even though we can measure its filaments and trace its clusters, we are still only observers looking at the galaxies from afar. To truly understand them, to know how they live, how they move, how they breathe, we must turn our attention to how we study them. And that, gently nudges us toward the next chapter, where telescopes of all kinds, optical, radio, infrared, X-ray, become our instruments for listening to the universe. Through their lenses and detectors, we gather faint photons from across time and space, assembling them into stories of how galaxies truly work. And so, drifting from the immense cosmic web, those filaments of galaxies stretched across unfathomable distances, we arrive at a quieter but equally wondrous place, the human act of looking. You see, all of these grand structures, all of these galaxies, clusters, voids, black holes, spirals, collisions, all of it reaches us only through the fragile medium of light. And perhaps, well, this is where the story becomes deeply human again, because the universe does not speak in words. It speaks in photons, and we, curious and restless, have built instruments to catch those whispers from across time. Many galaxies are too faint to see with the naked eye and require telescopes. In fact, if you step outside at night and look up, your eyes, magnificent as they are, can grasp only the tiniest fraction of what surrounds us. The night sky appears sparse not because the universe is empty, but because our biological senses are too limited, and so we build extensions of ourselves, mirrors, lenses, detectors, tools that gather light more patiently, more precisely, more deeply than our own eyes could ever manage. Optical telescopes collect visible light and show us the stars and bright regions of galaxies. These telescopes, from small backyard instruments to giant observatories perched on mountaintops, reveal the shimmering spirals, the glowing bulges, the delicate arcs of starlight. Through them, galaxies gain shape and character. But visible light is only a sliver of the cosmic spectrum, a narrow window onto a universe that shines in many unseen colors. Radio telescopes detect radio waves from cold gas and energetic processes in galaxies. These waves are long, gentle, and subtle, echoes from vast clouds of hydrogen, the raw material of stars. Radio telescopes can map structures that optical telescopes cannot see. The swirling arms of gas, the jets launched from black holes, the ancient remnants of dying stars expanding silently through space. When we listen in radio wavelengths, the universe seems to sigh with stories too quiet for human ears. Infrared telescopes can see through dust to reveal hidden star-forming regions. Dust, which obscures so much invisible light, becomes translucent in the infrared. Entire nurseries of stars, once masked by dark clouds, suddenly emerge, glowing softly in heat. It is as though the universe reveals its intimate secrets only to those who know which wavelength to look in. In infrared, we witness birth. Warm clouds collapsing, new stars emerging, galaxies glowing faintly with the slow warmth of starlight absorbed and re-emitted by dust. X-ray and gamma-ray telescopes reveal extremely hot gas and violent events near black holes and supernovae. These instruments capture the high-energy universe, a realm of turbulence and extremes. In X-rays, we see galaxy clusters filled with hot gas millions of degrees in temperature. We see the fierce radiation from accretion disks spiraling into supermassive black holes. In gamma rays, we witness the explosions of massive stars, the collisions of neutron stars, the darkest and brightest moments in cosmic history. It is a harsh, brilliant landscape, one invisible to our eyes but fundamental to understanding how galaxies live and die. Space telescopes avoid the blurring and blocking effects of Earth's atmosphere. This single fact reshaped astronomy. Above the distortion of air, above the scattering of light, above the warmth that blinds infrared instruments, space telescopes see with perfect clarity. They capture faint galaxies whose light has traveled across billions of years. They observe wavelengths impossible to study from the ground. They bring the farthest edges of the universe into sharp, trembling focus. The images they return, deep fields full of galaxies, each a story, remind us that we are tiny but capable of extraordinary perception. Long exposure images taken by large telescopes can reveal thousands of distant galaxies in what looks like an empty patch of sky. This is one of astronomy's quiet miracles. Point a telescope at a dark piece of sky, some tiny region with no visible stars, and let it gather light for hours or days. What emerges in the final image is a breathtaking field of galaxies, each one a world of stars. An ordinary human moment, a dark patch of sky, is transformed into a vast river of existence stretching to the edge of time. Spectroscopy, the study of how galaxies spread light into colors, reveals their composition, motion, and distance. When light is split into its component wavelengths, it becomes a kind of fingerprint. Patterns of dark lines tell us which elements are present. Shifts in those lines tell us how fast a galaxy is moving. The stretching of wavelengths tells us how far away it is. Through spectroscopy, astronomers read galaxies like books, books written not in ink, but in the bending and scattering of ancient light. The redshift of a galaxy's light tells astronomers how fast it is moving away because of the expansion of the universe. This is one of the most profound measurements in science. Light stretched into longer wavelengths, shifted toward red, reveals that space itself is expanding. And galaxies, carried outward on that expansion, recede from us at speeds proportional to their distance. The universe is not static. It is growing. It is stretching. It is becoming. Redshift is the measure of that becoming, the silent testimony of a universe in motion. Combining data from many telescopes and wavelengths gives a more complete picture of how galaxies work. No single instrument, no single color of light, no single technique reveals the full truth. A galaxy is too complex, too layered, too alive across too many scales. Only by blending the visible with the infrared, the radio with the ultraviolet, the X-ray with the gamma ray, can we see galaxies as they truly are. A symphony of phenomena, each wavelength playing a different note. And when all of those notes are combined, the universe becomes whole. Sometimes when I reflect on these tools, these telescopes, these detectors, these long exposures, I think of them as lanterns carried by humanity through the dark wilderness of the cosmos. Each new instrument brightens the path just a little more. Each new discovery reveals something that was always there but unseen. And perhaps that is what makes astronomy so deeply moving. It is not merely the study of distant galaxies, but the study of our own ability to reach beyond ourselves. In 2025, our telescopes, on mountaintops, in deserts, floating above the atmosphere, continue to push the boundaries of what we can know. And with each new advancement, we draw closer to understanding not only galaxies, but the future written in their stars. Yet even this vast observational power invites another question, one that whispers gently as we look outward across time. What comes next? If we can see how galaxies behave now, can we imagine their destiny, their transformations, their fading light? And that, is where we quietly step toward the next chapter, into the far future of galaxies and the cosmic address we call home. And so, as we drift from the instruments that let us study the universe, those quiet machines that gather ancient light, we arrive at a far more contemplative horizon. You see, once you learn how we observe galaxies, the next natural question is gentle but profound. What happens to them next? What becomes of these islands of stars as the universe grows older, as time stretches onward, as energy thins across expanding space? And well, perhaps this is where the story becomes both cosmic and deeply intimate. Because the future of galaxies is also the future of us, of our solar system, of every atom that makes up the world we call home. The universe is still expanding, and galaxies outside our local region are moving away from us. We see this not through imagination, but through the unmistakable redshift of their light, the stretching of wavelengths as space itself grows. And with that expansion comes a subtle but relentless consequence. The farther a galaxy is, the faster it recedes. It is as though the fabric of the cosmos is a great breath, and we are living inside its slow exhale. Over extremely long timescales, distant galaxies will move so far away that their light may no longer be visible to us. Imagine a night sky where the vast majority of galaxies, the ones we see today in deep field images, have simply faded from view, carried beyond the cosmic horizon by the accelerating expansion driven by dark energy. It is a strange thought. The universe, once full of brilliant islands of light, will appear emptier, quieter, lonelier, and in that distant future, the only galaxies still visible will be those gravitationally bound to us, those within our small cosmic neighborhood. And among those neighbors, of course, the greatest companion is Andromeda. The Milky Way and Andromeda are expected to merge into a single, larger galaxy in billions of years. Even now, in 2025, the two galaxies are drawing closer at hundreds of kilometers per second, though their ultimate collision will not occur until far beyond the lifespan of the Sun. It is not a violent crash, but a graceful interweaving, a long, slow dance unfolding across ages. Their stars will intermingle, their gas clouds will collide, their shapes will distort and merge, and eventually, the two magnificent spirals will become one enormous elliptical, or perhaps a giant swollen disk. Something new, born from the quiet collision of ancient forms. After the merger, the night sky would look very different, with new patterns of stars and gas. If there were observers still living on a planet, whatever world survives or arises, they would see Andromeda stretching across the sky in luminous arcs, then dissolving into the Milky Way structure until the two are indistinguishable. Tidal tails of stars would sweep the darkness like soft brushstrokes. The sky would glow with new star-forming regions lit by collisions of gas clouds. Entire constellations would shift and vanish as stellar orbits change, as neighborhoods of stars rearrange themselves in response to a transformed gravitational field. But this bright, vigorous phase will not last forever. Star formation in many galaxies will gradually slow down as gas is used up or heated. This process has already begun in many regions of the universe. Gas, the lifeblood of star formation, becomes scarce over time. Supernovae heat it. Black holes stir and energize it. Cosmic expansion thins it out. And slowly, galaxies enter a quieter age, where the birth of new stars becomes rare. A galaxy becomes like an aging city. Its most brilliant lights dim, its growth slows, and its once crowded nurseries fall silent. In the far future, most stars will be smaller, cooler, and longer lived than our Sun. Massive stars burn their fuel quickly and die young, often in millions of years. But red dwarfs, tiny, stable stars, can live trillions of years, far longer than the universe's current age. As time stretches forward, these small, dim stars will dominate the cosmos. Galaxies will shine not with the blue light of youthful giants, but with the soft, steady glow of ancient embers. The universe will lean toward red, toward quiet, toward endurance rather than brilliance. Eventually, galaxies will become dimmer as their brightest stars die and are not replaced as quickly. Supernovae will grow rarer, stellar nurseries will fade, spiral arms may lose their definition as new stars cease to replenish their structure. Ellipticals will remain, vast and slow, filled with old stars drifting like elders in a cosmic retreat. Over trillions of years, even the long-lived stars will burn out, leaving behind white dwarfs, neutron stars, black dwarfs, remnants of a universe that once blazed with light. Dark matter and dark energy will continue to shape the large-scale structure and fate of galaxies. Dark matter will hold local groups together, preventing gravitationally bound galaxies from drifting apart even as the rest of the universe expands beyond reach. Dark energy, meanwhile, will accelerate the separation of distant galaxies, pushing them away faster and faster. These two invisible forces, one holding, one expanding, write the final chapters of cosmic architecture. And through all of this, one truth remains quietly miraculous. Our Milky Way is just one of countless galaxies, but for us it is the entire cosmic neighborhood we call home. It is our address in the universe, the vast structure inside which every human story has unfolded. And learning about galaxies helps us understand not only where we are in the universe, but also how rare and precious our own world might be. After all, we emerged not from a void, but from the long, slow evolution of a galaxy that provided a stable environment, heavy elements, and time, enormous stretches of time, for life to awaken. Sometimes, when I reflect on the future of galaxies, I imagine a distant observer, living trillions of years from now, looking up at a sky nearly empty of light. Their universe would feel smaller, more isolated, its history hidden behind horizons they cannot see. And I wonder, you know, what they would give to know what we know now, to see the rich sky of 2025 overflowing with galaxies, spirals, clusters, filaments, all shining together like a grand cosmic choir. But we are here now, and we can see it. And perhaps that is our privilege, to witness the universe in its age of light, when galaxies are abundant and the cosmic web still glows with structure. And as we let this final chapter settle softly around us, there is still one more step to take. For though we have walked from the birth of galaxies to their far future, the story is not quite finished. There remains the closing reflection, where all these 100 facts gather into something quieter, something closer to meaning. And that, is where we drift next, toward the final gentle conclusion of our journey through the galaxies.